Assalamualaikum and greeting everyone. I am Muhammad Kamari Shambin Muhammad Zainuddin, a final year of student of chemical engineering. Welcome to my research project 1 presentation. Today I would like to present my project entitled Characterization of mountain bamboo cellulose fiber polymer composite using waste polypropylene container, supervised by Dr. Sufiana Binti Akbar. But first, this is the table of the content throughout the presentation that I will be talking about. The first part is introduction, where I will brief an overview regarding this project. The background of the study: Malaysia is tracking global trends in both the overall generation of plastic waste and the consumption of single-use plastic, and since 2017 has been the world's largest importer of plastic waste. Among of its, polypropylene (PP) is identified give the impact of the environment, as it takes very long time in landfills, which is about 20 to 30 years, to be fully decomposed. Plastic products often break down into very small fragments called microplastic that can pollute ecosystem and harm organisms. It can be finding PP in all types of plastic goods and plastic packaging. For example, in household items such as food packaging, bottle caps, yogurts, pots, tighter, and much more. PP is also suitable for blending, reinforcing, and filling. As a result, several studies have documented composite material that use PP as a material and cellulose fiber (CFS) from different plants as a reinforcement. Bamboo is possibly the best source of available for cellulose-based fibers. It is a quickly growing plant that is considered as a good source of cellulose fiber due to its high cellulose content and relatively small microfibrillar angles. One of the most popular species of the bamboo in Malaysia is mountain bamboo, and have been selected as a good choice for industrial usage because of its uniform size, thick, comes wall, and ease of cultivation. The advantages of the reinforced green composite over conventional synthetic reinforced fiber, such as its simple processing, low cost, low energy consumption, lightweight, renewability, and recyclability, also have attracted a lot of research interest. The problem statement: what issue arise that inspired me to do this project? The waste polypropylene can cause several issues towards the environment, such as can pollute ecosystem and harm organisms. Therefore, the researchers are looking a method to reduce the waste of polypropylene. Besides recyclable, PP also is suitable for biodegrade. Furthermore, they also had no impact on the fiber qualities to separate cellulose fiber using a chemical treatment with a direct technique using nitric acid and hydrogen peroxide. There are two objectives for this study, which is to blend mountain bamboo cellulose fiber with waste polypropylene at 3 different cellulose fiber composition, as well as to characterize the chemical bonding, thermal property, and morphology of waste polypropylene and cellulose bamboo composite. The next part is novelty of the research. What is the difference of polypropylene reinforced by cellulose fiber from based on different plant? Actually, there are more different of polypropylene reinforced by cellulose fibers based on different plant, but now I will highlight it for the weakness from aspect of different plants. First thing first, I will highlight about the weakness of polypropylene reinforced by cellulose fiber, the extraction from straw. The thermal stability of composite tends to decrease with increasing CF contained due to the low thermal property of the CF. However, from the table, 10 weight percent with lowest temperature of all composites show high temperature at over 300 degrees C. Pure PP practically did not lose weight at 400 degrees C. However, its weight loss occurred rapidly from 462 degrees C, resulting in minimal residue. Next is based on sugarcane case. By FTIR analysis, after fibers acetylation, the appearing of acetyl group and decreasing of OH bond were evident, and its displacement was from 3,400 to 3,700 per centimeter. The acetylation changed the morphology of fibers, resulting in agglomerates with globular form. This SEM micrograph of cellulose C and D below show that the chemical modification was not so soft and promote the hard change in morphological aspect of fiber that could influence in the composite properties. Then we move on to the next part, which is methodology. How I will conduct my research. The waste polypropylene container with numbering at 5 at bottom is collected from waste and soaked in water to wash them. The material is shredded into small material or called as flakes by using crusher. After that, the material is dried in a room temperature. Meanwhile, the cellulose fiber from spanta bamboo extracted using the chemical treatment are collected from Faculty of Chemical Engineering. Lastly, virgin polypropylene has used. The internal mixer will be used to blend the collected waste PP and CF. Table below shows the blend composition percentage by weight of PPs and CF that use. The blending process will be carried out at 180 degrees C temperature, 40 RPM rotation speed, and 5 minutes residence times. The sample then will be crushed for the characterization testing. The schematic diagram of the overall methodology is shown in figure. The characterization of blended PP and CF are evaluated by using FTIR, DSC, and TGA, while the morphology is analyzed via SEM. Fourier transform infrared FTIR spectroscopy in range 400 to 4000 per centimeter with resolution of 40 per centimeter is used to determine the change in functional group of samples. The samples are grounded into powder and blended with high purity dried potassium bromide before pressing into ultra-thin transparent pellets. To perform the acid testing, the composite samples are cut and placed in an aluminium plate in nitrogen atmosphere for heating. The thermal program for the acid measurement was performed at 3 stages. Stage 1, sample heating in calorimeter at 10 degrees C per minute, heating rate from 30 degrees C to 200 degrees C. Stage 2, 200 degrees C for 3 minutes, applied to remove crystalline nuclei. And stage 3, cooling the sample 30 degrees C in calorimeter at 10 degrees C per minute, which is a cooling rate. The thermal stability and degradation temperature of composite are analyzed by using thermogravimetric analyzer. The samples are heated from 30 to 800 degrees C under nitrogen atmosphere at a heating rate of 220 degrees C per minute. The morphology of the composite will be analyzed using SEM. The fracture surface of composite is observed with accelerating voltage at 15 kV. Sample designation are spattered with cool prior to observation to avoid surface changing during the test. That is all from me. Thank you for listening my RP presentation. Hoping that we will gain some knowledge from my presentation. Have a nice day.